Okay, hi, welcome back. So we are in our video series for Unit 3, which is all about evolution. And so we started this Unit 3 series learning about homeostasis and the human body systems and how our body maintains balance and in all of our different systems and how they work together to keep us at the right temperature, to keep our blood sugar levels right, to keep our blood pressure right, our water and electrolyte levels balanced. So we started off with that, and then we went into how bacteria and viruses make us sick. And so in today's lesson, we are going to look more in depth at bacterial reproduction. And so in the video right before this, we talked about how bacteria reproduce and how viruses reproduce. And we know that bacteria reproduce through binary fission, and that's just another form of mitosis. So bacteria, they don't have eggs and sperm. They just make a copy of their DNA and then split in half, just like mitosis. And so they can do that very rapidly. So that's what we're going to look at today, as well as, some bacteria are good, but some bacteria make us sick. And so we learned that the bacteria that make us sick can be treated with a medicine called antibiotics. And so we're going to look at today, we mentioned that some bacteria are becoming antibiotic resistant, meaning that the bacteria are getting stronger than the antibiotic medicine that's supposed to kill them. And so we're going to look at why it is so important to take all of your antibiotics when you're sick, and how when we don't take all of our antibiotics, how that is impacting the ability of the antibiotics to kill the bacteria. So first, let me share my screen. We're going to do a little bit of math today. Hold on. Here we go. So yeah, a little bit of math today. And one of the first concepts I want us to look at, and in this, we're going to make a mathematical model that will help us understand bacterial reproduction and what happens to bacterial reproduction in the presence of antibiotics as well. So we know that bacteria can reproduce very rapidly. In fact, they can reproduce every 20 minutes. So unlike humans, that takes us 9 months to reproduce and make a baby. Actually longer than that for the mama to get ready again. But there are people that have children 1 year apart, but it's on a minimum, it's a year between reproduction cycles for humans. But for bacteria, they can reproduce every 20 minutes. Okay, so we know that in 1 hour, there are 60 minutes. So if we divide that 60 minutes by 20 minutes, then that is 3 times in an hour that a bacteria can reproduce. So every 20 minutes, that means it reproduces 3 times in an hour. Okay, so if we start, if we have a bacterial population and we just have one bacteria cell, well, you can't even see it. You would need a microscope to be able to see it. But let's just say that we touch a surface like a keyboard, for example, that somebody coughed or sneezed on, and we get a teeny tiny little droplet and on our finger, and then we scratch our eye, or we rub our nose, or we put our finger in our mouth, whatever reason. But that whatever is in that little droplet is going to get inside of us if we do that. And so even if there's just one bacteria cell in there, over that next hour, that one bacteria cell is going to reproduce itself, replicate itself every 20 minutes. So times 2, times 2, times 2. So in 1 hour, we are going to have 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. We're going to have 8 bacteria cells in 1 hour. So this is 0 hours. We start with 1. Now, in 1 hour, we have 8. Those 8 are going to start reproducing. Every 20 minutes, they're going to replicate themselves. So 8 times 2 times 2 times 2. So 8 times 2 is 16, times 2 is 32, times 2 is 64. Now we're going to have 64 bacteria in 2 hours. So at 2 hours, we have 64 bacteria, and I am going to need a calculator pretty soon. So I'm going to get it ready. But those 64 bacteria from 2 hours to 3 hours are going to replicate 3 times. Times 2 times 2 times 2. So 64 times 2 is 128. 128 times 2 is 128 times 2 is 200. Well, I need my calculator. So 128 times 2 is, whoops. All right, let me just start from the beginning. 64 times 2 times 2 times 2 equals 512. At 3 hours, we have 512. So now it's just going to keep going. Okay, they're just going to keep doing what they do, keep reproducing. So from 3 hours to 4 hours, they're going to multiply, replicate themselves every 20 minutes. So 512 times 2 times 2 times 2 equals 4,096. At 4 hours, we have 4,096 that they're going to start replicating between 4 and 5 hours. And then we're going to have 32,768. 5 hours, we have 32,768. Those replicate every 20 minutes. Now we have 262,144. Now we have 2 million. Okay, so 2 million plus in 6 hours. That's incredible, isn't it? So one little bacteria cell became 2 million bacteria cells in 6 hours. So you're sick at this point. You probably didn't feel bad until you got up here to between the 5th hour and the 6th hour. You have a lot of cells in your body. You have 1 trillion cells in your body at least. And so 32,000 little bacteria cells in 1 trillion cells is just kind of a drop in the bucket. But when you get up to 2 million bacteria cells, you're going to feel sick. So you feel bad. These guys just keep on replicating, and you figure out, or your mom figures out, that you need some medicine. Okay, so luckily we have antibiotics that kill most bacteria. And so let's look at what happens when we start taking antibiotics. Okay, so if you look at this chart, we're going to do another model to determine how many doses of antibiotics you would need to take if you had 1 million bacteria cells in your body. Okay, just we're keeping the numbers even to make it easier. And although antibiotics are very effective, they're not 100% effective. So to make our math easier, we're going to say that this antibiotic is 90% effective. Most antibiotics are more effective than that. But you'll see what happens even in our next model. We're going to do an antibiotic that's 99.99% effective. And even then, it's still not 100%. So let's look at a model, a simplified model of what happens to the bacteria each time we take a dose of antibiotics. So at 0 doses, we have 1 million bacteria cells. Okay. We take an antibiotic that is 90% effective. So we are going to kill 90% of this million. So I'm going to multiply times 0.90, and that's going to give me 900,000 bacteria that we are going to kill. So we're going to kill 900,000 bacteria. Okay, that's going to give us a lot of a relief. We're going to feel a whole lot better, but it's not, we didn't kill all of them. So 1 million minus 900,000 means that we have 100,000 bacteria alive still after 1 dose. Okay, so we'll make this a 1. This will make it easier because it says number of bacteria before the dose. So on our first dose, we had 1 million, we killed 900,000, and so we have 100,000 left. Okay, so we got to take some more antibiotics. So we're going to take a second dose, and we only have 100,000 alive before this dose. So 100,000 times 0.90, we're going to kill 90%. So that means we're going to kill 90,000 of them. And so if we subtract 100,000 minus 90,000, that means we only have 10,000 left alive. But we can't stop taking our medicine yet. We got to kill them all. So on your third dose, you've got 10,000. We're going to kill 90% of them. So 10,000 times 0.90 is 9,000. 10,000 minus 9,000 leaves 1,000 alive. Are you noticing a pattern here? Yeah. Our fourth dose, we've got 1,000 left, 1,000 bacteria alive before we take our fourth dose. We take our fourth dose, we kill 90% of these. So 1,000 times 0.9 is 900. So 1,000 minus 900 that we killed leaves 100 bacteria. All right, our fifth dose, we have 100 bacteria. We take our medicine, we kill 90%. 90% of 100 is 90. 100 minus 90 is 10. All right, our sixth dose, we have 10 before we take it. We kill 90%, so we kill 9, and we only have 1 bacteria left. Okay, we have to take 1 more. Believe it or not, we have to take 1 more. So on our 7th dose of antibiotics, we have 1 bacteria cell left alive. We kill 90%, so we kill 0.9. Okay, so we kill 9/10 of a bacteria. So if you kill 9/10 of a bug or an animal, that animal is going to be dead. So the same thing with bacteria. If we kill 9/10 of a bacteria cell, they're gone. It's dead. So we finally get to 0 bacteria cells. But it took 7 doses of our antibiotics. So you see why it's important to take all of your antibiotics. And one thing that you would, after you take this first dose and you only have 100,000 bacteria left, you feel a lot better. And when you get down here after your second dose and you only have 10,000 left, you're going to feel like you're not sick. Okay, but you have to keep taking them. And so to show you a little more realistically what is happening here, so you got to realize that you're taking an antibiotic, several doses, but you can't take them one right after the other. You take them usually like every 4 hours, depending on what the doctor tells you to do. But we're going to look at a mathematical model. We're going to create a model that shows what is actually happening when you take into consideration that in between your antibiotic doses, those bacteria are still growing. So it's really the actual scenario that goes on in our bodies when we're sick is really a lot more complicated than this right here. So let's look at that next. And we need a chart, a little bit different kind of chart for this one. So as we build this mathematical model, what we're trying to accomplish is we're trying to predict what would happen to the bacteria population hourly if there's a few certain conditions that we're working under. So if we start out with an initial infection of 1 million bacteria, just like our previous model, and we take our first dose of antibiotics immediately at hour 0. And this time, though, we're going to say our antibiotic is 99.99% effective. So this is very effective, this antibiotic. We're also going to assume that the bacteria can reproduce every 20 minutes and that we take our dose of antibiotics every 4 hours for 24 hours. So at the end of 24 hours, we want to see if we have any bacteria left alive. Okay. So at 0 hours, we have 1 million bacteria. Okay. And we are going to take our antibiotic, and remember our antibiotic is 99.99% effective. So since this is a percentage, we're going to change it to a decimal by moving the decimal over 2 places to the left. So the number we're going to be multiplying by is 0.9999. Okay, so I'm going to show you my calculator as we work through this. I think I'm going to need to, let me fold this down because this is a long chart. All right, so okay, so we have 1 million bacteria cells, 6 zeros, and we're going to take our antibiotic that is 99.99% effective. So we're going to multiply times 0.9999, and that means that we are going to kill 999,900 bacteria on our first dose. So if we subtract, I'm going to write that 999,900. Okay, that number we're going to subtract from 1 million. So 1 million minus 999,900. Wow, we only have 100 bacteria left. That's some pretty powerful medicine there. Okay, so we have 100 bacteria left. We are going to feel wonderful after taking just 1 dose of our antibiotics. Okay, 100 bacteria is nothing in our bodies. Okay, so some of us may be tempted not to take all of our antibiotics at this point because we feel so much better. But we know that every 20 minutes, these 100 bacteria are going to replicate, right? So in 1 hour, so from 0 hour to 1 hour, we killed almost all of them. But in 1 hour, these 100 are going to replicate every 20 minutes. So 20, 40, 60, 3 times. So 100 times 2 times 2 times 2. And so in 1 hour, we're going to be back up to in 1 hour, we have 100, but they're going to replicate every 20 minutes. So in 1 hour, we're going to have 800 bacteria. Okay. Now we can't take our antibiotics every hour. We have to wait 4 hours. Okay. So in another hour, these 800 will replicate every 20 minutes. And in 2 hours, we'll have 6,400 bacteria. They're going to replicate every 20 minutes. And so in 3 hours, we will, let me make sure I'm doing that right. Yeah, in 3 hours, we'll have 51,200. And in 4 hours, we'll be back up to 409,600 bacteria. Okay. Okay, now we feel bad again. So now we're like, oh, I better take my next dose of antibiotics. So I'm going to take my antibiotics, and so I have 409,600 bacteria. I'm going to kill 99.99%. So 0.9999. And that means I'm rounding to the nearest whole number, because you can't have a half of a bacteria. If you have a half, then it's gone, it's dead. So we're going to round to the nearest whole number. So since I have a 0.0, I am just going to round to 409,559. Okay. So I am going to subtract 409,559 bacteria from my original population, 409,600. And that will leave me with 41 bacteria. Okay, and then again, now I feel great and I feel like I'm not sick anymore. But between 4 hours and 5 hours, these bacteria are going to reproduce every 20 minutes. So 41 times 2 times 2 times 2 equals, so in 5 hours, I have 328 times 2 times 2 times 2. In 6 hours, I have 2,624. In 7 hours, I have 20,992. In 8 hours, I have 167,936. Okay, so I've made a significant dent in my infection with just 2 doses. But if I don't take my 3rd dose, this 167,000 is soon going to become 1 million again, right? Because it's just going to keep on multiplying. So it's been 8 hours now, so I can take my antibiotic. So I am going to multiply times 99.99%, so times 0.9999. And so that means I'm going to kill 167,919. Okay, I'm going to ignore the 0.2 because I can't kill just 2/10 of a bacteria. Okay, so I'm just going to go, I'm not going to round up because that's a 2. Now, if this number, this first number to the right of the decimal is 5 or higher, then I'm going to round this number up. Okay, so I'm going to subtract 167,919 from the population, because that's the number I'm going to kill. And now I only have 17 bacteria left. Okay, and this is the time when people are really tempted to not keep taking their antibiotics. Okay, and you'll see why when we get to that point. So now we only have 17. So those 17 are going to start reproducing. So 17 times 2 times 2 times 2. So in 9 hours, I have 136 times 2 times 2 times 2. In 10 hours, I have 1,088. In 11 hours, I have 8,704. In 12 hours, I have 69,632. So you may not feel sick at this point. It just kind of depends. But this is where people fail to take their antibiotics like they're supposed to. When you get down to this low of a number of bacteria cells, you feel better. And so you feel like you don't need them, but you know what's going to happen. Those 69,000 are going to soon, within a few hours, be over 1 million again. Okay, so we got to take our, let's see, that'll be 1, 2, this will be our 4th dose. So we're going to kill 99.99% with our 4th dose, which is 69,625. We're going to subtract that from our population before we took our 4th dose. And we only have 7 bacteria left. Okay, we are getting so close, but we can't stop yet. So the 7 will begin to do their thing. They will begin to replicate. So in 13 hours, 7 times 2 times 2 times 2 equals 56. Now, I don't know if you guys have thought of it yet, but I'll show you a little trick if you have to do this on your own. 2 times 2 times 2 is 8. 2 times 2 is 4, times 2 is 8. So you can just do times 8 and you'll get the same answer. So you can save yourself a few punches on the calculator. So in 14 hours, you're going to have 448. In 15 hours, you're going to have 3,584. And in 16 hours, you'll have 28,672. You're going to take your 5th dose of antibiotics. Let's see, 1, 2, 3. Yeah, this will be our 5th. So we're going to kill 99.99%. We're going to kill 28,669. And notice we have a 0.1, so we're not going to round up. We'll leave that a 9. We're going to subtract. The original populations was 28,672. We killed 28,669. Now we only have 3 bacteria left, and we can't stop. We do not feel sick at all anymore. Okay, this has been a couple of days that you've been feeling better now. And so, or a few hours that you've been feeling better now. And usually, this is every 4 hours, but usually doctors will prescribe you to take 2 antibiotics a day, so one every 12 hours. So instead of just taking a few hours, this actually takes several days. Okay. But when you get to this point where you only have 3 bacteria cells left alive, and before that, you only had 7 left alive, you're tempted to quit taking your antibiotics, but you can't. Okay. So 3 times 8. So in 17 hours, you have 24 times 8. In 18 hours, you have 192 times 8. In 19 hours, you have 1,536. And then in 20 hours, you have 12,288. You take your 6th dose and you kill 99.99%. So that means you kill 12,280. Oh, look, it's 286.7. Okay, so we have to round up here, because 0.7 is more than 0.5 or higher. So that's how you do rounding. You remember from math class, if you're rounding to the whole number, because we can't have a partial bacteria cell. We have to have either a whole bacteria or none. So we have to have whole numbers for these calculations to be realistic. So since it's 0.7, that means that 6 is going to become a 7. So that means we've killed 12,287. So 12,288 was what we had before the dose. And then we killed 12,287. So that leaves 1 bacteria cell. Now, look, remember, let's see, where is that paper? Remember what happened. Remember this model that we made. Remember, we had 1 bacteria cell, and then in 6 hours, that 1 became 2 million. You cannot quit taking your antibiotics yet. You're not there yet. Okay, so your doctor has calculated exactly how much antibiotic you need to kill every last one of those bacteria cells. So we are going to keep going. So every 20 minutes, that 1 will make a copy of itself. So 1 times 8 is 8. So in 21 hours, we have 8 times 8. In 22 hours, we have 64 times 8. In 23 hours, we have 512. And in 24 hours, we have 4,096. So we've got to take 1 more dose. So we're going to kill 99.99% of those. And we are going to kill 4,090. Now look, this is where the rounding is important. We have 0.5. So that means that that 5 on the left side of the decimal is going to get rounded up. And we're going to kill 4,096. So 4,096 minus 4,096 is 0. So we can finally stop taking our antibiotics, and we did it right. We killed every last one of those bacteria cells, and we didn't leave any to reproduce and make us or someone else sick again. Okay, so that is how bacterial reproduction in the presence of antibiotics works. Thank you for listening, and I'll see you next time.